With this part of our equilibrium experiment, we are going to be looking at the equilibrium system involving iron thiocyanate, a red complex. Now we make the iron thiocyanate stock solution by mixing a solution of iron-free nitrate and potassium thiocyanate. Now, both of these solutions are clear and colorless. If we mix these two solutions, however, we generate an ion, a complex that has a color. This is going to be our stock solution for our experiment. We're going to start with this as our basis, and then just try and disrupt the equilibrium. At the moment, what we have is not just this thiocyanate complex, but rather a mix of that red complex and the original ions that we put in solution. So in this beaker right now, we have both our reactant side and our product side to this. So I'm going to transfer a small amount of my stock solution to several different test tubes. I'm going to use this as my control, so I always have a reference for the original color. That's going to make the comparison significantly easier when I disrupt the equilibrium. And I'm trying to decide, well, did I make it more red or did I lower the intensity of that red color? There are a few disruptions that we're going to try and do. One disruption is going to involve adding a more concentrated amount of the potassium thiocyanate. Another disruption is adding some 0.1 molar iron-free nitrate. In another set of experiments, we're going to look at how temperature affects the equilibrium. And remember, temperature is going to affect equilibrium and shift it either left or right, depending on whether we have an endothermic or exothermic reaction. Our rule of thumb is that adding heat is going to push our equilibrium or our reaction towards the endothermic direction. So here we have our test tubes for my control, my addition of the thiocyanate, and my addition of the iron. I'm going to move my control over here so it's easier to see the two variable test tubes. Now these two test tubes I'm going to place into a hot water bath, which I have set up here, and a cold water bath, which I have set up here. I'm going to let these two sit in the background while we work with our other test tubes. So the first disruption we're going to do is with the potassium thiocyanate. We're going to add a few drops to our test tube and see what happens to the color. Again, it's going to be best to compare this to our control. So we can use this color shift to tell us whether we have gone to the left or the right. And in our equilibrium, again, the product that our two ions make is the intense red color. Next, In our third test tube, we're going to add the 0.1 molar iron-free nitrate. Just a few drops. And again, we're going to compare the color against our control. And again, we use the color change to tell us, did we shift to the left or to the right? Okay, we are back. We're now looking at the hot and cold test tubes of our equilibrium reaction. And so as you can see, there's a little bit of difference in intensity in the color. So in the hot and cold we have here, right? Again, the one with the label has the blue, that is the hot one, and there is our control as well. Now it is a bit difficult to tell the difference against our control this time. So what we're going to do instead is look at the hot versus the cold. In which version did we shift to the left? In which version did we shift to the right? If we're just comparing these two test tubes to each other. By comparison, we'll also be looking at a cobalt equilibrium. This cobalt equilibrium has a pink reactant and another reactant that is colorless, and then the product is blue. And as a result, at equilibrium, we have sort of this purple mixture. We'll be taking a look at that separately in another demo.